Okay, this is a quick rundown on lesson 5.5. I'm going to try to do this as quickly as I can because I know you probably don't want to watch this for too long, but maybe it'll help you if you had a chance to read this. I'm going to go through the properties of this distribution. The title is called Properties of the Sampling Distribution of the Sum and Difference of Two Different Populations. So I also have some notes that I'll send you, so if you don't catch this fast enough, you can follow along on those. The basic idea is it's going to look and feel a lot like the other problems we've done. What we're going to do is we're going to take samples from two different populations. So let's say you have, I don't know, male and female. We'll just split up two different populations. And let's say the males have an average of whatever this problem is. It doesn't even really matter. An average of 72. Maybe it's heartbeat or something like that. It doesn't matter. The females have a average of 70. And let's say the standard deviation here is 3. The standard deviation here is 4. Basic question is going to be, if I take one male and one female and combine them, I'm going to ask something about either their sum or their difference. So the question might be, what's the probability the sum is greater than, I don't know, let's say 140. So there would be a question like that. Or maybe probability that the difference is less than 4 or something like that. So we're taking one person from here, one person from here, and then we're asking a question about it. There is a little simulation in the book. If you want to look at it, it's very similar to the simulations we did in class, where you can actually simulate this. You know, you could maybe have one, but I think the example in the book is rolling a dice or 2 dice. So you just have the same population actually, and then you can check all the possible combinations. It's the same thing here. The sampling distribution is if you took all of the males in the population and all the females in the population and took every possible combination of those two, one male, one female, one male, one female, and added them up or subtracted them, whatever, you get a new distribution. The question is basically, just like it's been on the other sections, what does that distribution look like? What's the mean? And what's the standard deviation? And then we can answer this question very easily once we know that mean and standard deviation. So I'm going to erase this board here. And I'll give you the properties. And then once we have the properties, we can do the example problem very quickly. So here are the properties. These are the properties of that sampling distribution. First of all, the samples must be independent. So that's the first thing when I take the samples. The two groups must be independent. The two populations must be independent of each other. And both populations need to be normal. In order to do this, one will be normal. If they're both normal, then the sampling distribution will also be normal. All right. So here are the properties. We'll do the properties of the sum first. I'm going to draw it on a normal curve. Properties of the sum. The curve will be normal as long as both the populations are normal. Let's say population 1 has what we call mean 1 and standard deviation 1. And population 2 would be mean 2 and standard deviation 2. So when we do all the possible combinations, what's going to happen is we're going to get a normal curve as long as both populations are normal. The mean of this normal curve is probably what you would expect is mean 1 plus mean 2. We just add the two means together, it's going to give us the mean of the distribution. If we do the difference, it's exactly what you expect also. It's going to be a normal curve, and the difference is going to be mean 1 minus mean 2. Just like in our other populations, the population mean is equal to the sampling distribution mean. The population proportions equals the sampling distribution. Standard deviation, same thing here. Just add them together. Just make sure on this one that you subtract the same way every time when you're doing the problem as you go through it. The standard deviations are going to be a little different, maybe not what you expect. The standard deviation of this distribution is going to be, whoops. You can't actually do any work with the standard deviations, but you can with the variance. So you might remember this term is called variance. You square the standard deviation of one, and you square the standard deviation of the second one, and you add them together. I'm sorry, you square them, get the variances, add them together, and then you take the square roots. That's going to give you the standard deviation. If you just add the two variances together, you'll get the variance of this one, which is kind of a nice little property, but the variances don't help me in the problem. We need the standard deviation. So add the two standard deviations together, the two variances together, sorry, you'll get the new variance, take the square root. And believe it or not, it's the same thing over here. You can't subtract the variances because it's going to get smaller. This is going to get more spread out. You might remember there's a test, a problem in chapter 2 about two populations. You put them together, they'll get more spread out. So this one actually has the exact same standard deviation also. Variance 1 plus variance 2. Add the two variances together and then take the square root. So I have this little note sheet that will tell you that. It's also in the book. I'll send this to you. But an example problem might help. So let's do an example problem. So I'm going to erase all of this now. Give me a second. All right. So here's the question. It's the same question that's in the book. So if you want to follow along the book, you can. You read it. The question is, we have bottle caps that are manufactured by a company, and the bottle caps have a diameter, an average diameter of 36 millimeters, and it has a standard deviation of, we'll call this standard deviation 1, I guess, of 1.2 millimeters. Then we have bottles themselves. The bottles have an average diameter of 35 and a standard deviation of 1. And the question is, if we pick, this is our company trying to see if this is going to fit, if we pick one cap and one bottle at random, what's the probability the cap will actually fit on the bottle? Probability cap fits on bottle. So we're going to actually oversimplify this a little bit because it's a little silly, because clearly if the cap is way too big for the bottle, it's not going to help our company. But we're just going to just say that what's the probability that the cap is greater than the bottle. Because if the cap is greater than the bottle, the cap's going to fit on the bottle. Which also means what's the probability that the cap minus the bottle is greater than 0. We want to think about this as a subtraction problem, because we can either add the two or subtract the two. Those are the two distributions that we have. So we're trying to figure out what's probably cap minus bottle is greater than 0. Pretty straightforward problem. You'd have a normal curve. I have to tell you that these two populations are normal, so that would be given to you in the problem. So the two populations are normal. If I do cap minus bottle, the distribution of cap minus bottle, the mean of the cap minus bottle is just the whole distribution together. As I combine them together, it's just going to be whatever the mean of the cap is minus the mean of the bottle. The mean of the cap is 36. The mean of the bottle is 35. So the difference is going to be 1. If we were adding them together, it would be, of course, 71. Now we need the standard deviation of this distribution. Standard deviation, remember, it's the formula I just gave you. So the standard deviation is you can add the two variances together. So you can do 1.2 squared is the standard deviation of bottles, plus 1 squared, which is the standard deviation of the caps, the bottles, and then you take the square root of that. That's your standard deviation. And then the question is pretty straightforward. We just want to know if cap minus bottle is greater than 0. So we're looking for that. So I'll do a quick erase of this just so you can see the finish question. And we'll be finished. Hopefully this example is enough to help you. We're just now going to do normal CDF as we normally would, from 0 to infinity, with a mean of 1 and a standard deviation of square root of 1.2 squared plus 1 squared. I don't have my calculator with me, it's in the house, so that's it, how we finish up. And hopefully that's enough to help you get through this section. And if you're watching this, I'll see you in class on the block day.